What if I told you humanity just touched the sun? Not in theory, in reality. NASA's Parker Solar Probe has flown straight into the sun's atmosphere, capturing images and data so intensely, they're reshaping everything we thought we knew about our star. From rivers of superheated plasma to violent magnetic twists that could knock out satellites. What this spacecraft saw is not just fascinating, it's urgent. Because what happens 93 million miles away doesn't stay there. Keep watching, because what NASA just discovered might change how we see the sun and how we protect ourselves from it. The mission is named after physicist Eugene Parker, who in 1958 proposed the revolutionary idea that the sun constantly emits a stream of charged particles, the solar wind. At the time, many doubted him. Today, his theory is a pillar of space science, and now, a spacecraft bears his name. Launched in 2018, NASA's Parker Solar Probe was built for one purpose: to get closer to the sun than any spacecraft in history. It doesn't just orbit, it dives into the corona, the sun's superheated outer atmosphere. On December 24, 2024, the probe completed its most daring flyby yet, coming within just 3.8 million miles of the solar surface. To put that into perspective, it's about 1/10 the distance from Mercury to the sun, and well within the sun's corona. To survive, Parker is wrapped in a carbon composite heat shield capable of withstanding temperatures over 1,300 degrees Celsius, 2,400 degrees Fahrenheit, while keeping its internal instruments at room temperature. But the biggest challenge wasn't heat, it was turbulence. Inside the corona, the magnetic fields are twisted, the plasma chaotic, and the environment utterly unpredictable. And that's exactly what Parker was there to study. Why is the corona hotter than the sun's surface? What drives solar storms and coronal mass ejections? And most importantly, how do these violent outbursts affect Earth? The only way to find out was to fly straight through the fire. As Parker Solar Probe pierced the corona, its sensors went into overdrive. The probe captured first ever close-up footage of the solar wind in its chaotic early stages. One of the most surprising discoveries? Magnetic switchbacks, sharp, zigzagging bends in the sun's magnetic field that violently flip direction. These switchbacks weren't predicted, and their abundance shocked scientists. They may be a key mechanism in propelling the solar wind and helping it escape the sun's immense gravity. Then came the big ones: coronal mass ejections, colossal bursts of charged particles that rocket into space at over 1 million miles per hour. Parker flew through the edge of a CME, offering real-time footage of shock waves and plasma structures we've only modeled until now. These CMEs aren't just pretty explosions. They're responsible for geomagnetic storms that can disrupt satellites, jam communications, and overload power grids. In 1989, a CME caused a blackout in Quebec. A bigger one could cripple modern infrastructure globally. The footage also showed that the corona isn't smooth, it's boiling magnetic chaos. Think of it like an ocean of electrified fire, constantly churning, merging, and flaring. One particularly jaw-dropping find was a series of CME collisions. Parker recorded multiple CMEs slamming into each other, fusing into larger structures and reshaping their paths. This phenomenon makes space weather even harder to predict and more dangerous. The data even hints that switchbacks and chaotic plasma waves are more widespread than expected, not isolated anomalies. For the first time, we're watching the solar wind being born, watching it twist, speed up, and break loose into the solar system, heading, eventually, toward Earth. So why should you care about what's happening 93 million miles away? Because what Parker is doing may one day protect your GPS, your internet, your power supply, and your future. Our civilization runs on satellites and high-precision systems, from communication and weather forecasting to financial transactions and military operations. But solar storms don't ask for permission. The Parker mission is not just a scientific feat, it's a warning system in the making. By studying how CMEs form, how fast they travel, and how they interact, scientists can predict major space weather events and issue alerts before they cause blackouts or disable satellites. That means safer navigation for aircraft, better protection for astronauts, more reliable global communications. Parker's findings are also driving the design of next-generation spacecraft. Vehicles that will be able to withstand extreme conditions, explore the outer planets, or even survive interstellar journeys. And then there's the science. We've studied the sun for thousands of years, but only now, by touching it, are we starting to answer questions like, why does the corona get millions of degrees hotter than the surface? What triggers slow versus fast solar wind? And how exactly does the sun shape space weather across the entire solar system? As Parker continues its mission, its next close pass coming in September 2025, we'll get even more data. We're not just observing the sun, we're learning how to live with it. For millennia, humans have looked at the sun in awe, reversing it, fearing it, relying on it. But now, for the first time, we've reached out and felt its touch. The Parker Solar Probe is not just a technological marvel, it's a symbol of what's possible when science dares to go further. We're not just passengers in the solar system anymore. We're explorers, mapping the very engine that powers our existence. And if we've come this far, imagine where we'll go next. If you like this video, hit like, share, subscribe, and let me know your opinion in the comments. Thank you for watching, and see you next time.